Hey students, this is lesson 712. What I'm going to do is do a couple of homework section problems with you, and then you can do the regular problems. So you'll be learning some skills here. Number 12 says, write and solve an equation to find the number of coins each friend has. Number 12, Ken has 3 more coins than twice the number Javier has. Caleb has 5 fewer coins than Javier. They have 50 coins altogether. So we want to write and solve an equation. We have 3 people. We have Ken, Javier, and Caleb. And it says that Ken has 3 more coins than twice the number Javier has. Caleb has 5 fewer coins than Javier. Since both Ken and Caleb are in terms of Javier, let's let X be Javier, how many Javier has. And then Ken has 3 more coins than twice the number Javier has, so we can just call that 2x plus 3 for Ken. And then Caleb has 5 fewer coins than Javier, so we can just call that x minus 5. And since they have 50 coins altogether, we can just combine these into one equation, adding them all up, so that our total is 50. And then we can just simplify that. 2x plus x is 4x, plus 3 minus 5 combines to make minus 2, and that equals 50, and now we can just work backwards to find x. And I'll let you finish that, and all you have to do is add 2 and divide by 4. And then, well, maybe let's do that. 50 plus 2 is 52, and divided by 4 is 13. So that means Javier has 13, Caleb has 5 fewer than that, which is 8, and Ken has twice Javier plus 3, so that'd be 26 plus 3 is 29. And if we did all that right, those 3 numbers should add up to 50, which I think they do. All right, let's try another one. It says Dechun has 5 times as many coins as Austin. Dechun also has 16 more coins than Austin. So what we're doing is representing Dechun 2 different ways. We have that he has 5 times as many coins as Austin. Let's just call that 5a. A being how many Austin has, and Dechun also has 16 more than Austin, which would be a plus 16. Now, for the equation here, we don't know the total they both have or anything like that, but we do know that Dechun has, the number he has is the same, whether we're talking about him having 5 times as many as Austin or him having 16 more than Austin. So our equation here is just going to be saying 5a equals a plus 16. And to solve that, we need to get a on just one side. So we're going to subtract a from both sides, and then we get 4a equals 16. Divide both sides by 4, and we get a equals 4. So Austin has 4. And that means that Dechun, we can look at it 2 ways. He either has 16 more than Austin, which would be 20, or 5 times Austin. 5 times 4 is 20, either way. So, all right, let's look at number 14. It says Cavill has 2 less than double the number of coins Ty has. Cavill also has 23 more than Ty. Actually, that's just like kind of like the last problem, so I'll let you do that. Let's move on down here. To number 19. It says Kenya and Laura were making hair ribbons to sell at a craft fair. Kenya cut 7 segments from one length of ribbon and had 2 feet left. Laura said, I'm cutting segments twice as long as yours. If your length of ribbon had been just 1 foot longer, I could have cut 4 segments from it. From their conversation, determine how long Kenya and Laura's segments were. So I think a good strategy here would be to make a diagram. So let's let's say this line here represents the ribbon. Okay, so it says, can you cut 7 segments from one length of ribbon and had 2 feet left? So let's just make those cuts here. So there's 1, and they're all the same length. So 2, 3, 4, 5, 6, 7, and then she said she had 2 feet left. So this space left over here is 2 feet. And then let's just call all of these lengths x. And if you think about it, we can represent this drawing with an expression. We have x 7 times, and then plus an extra 2 to represent that. Now it says, can you, Laura said, I'm cutting segments twice as long as yours. If your length of ribbon had been just 1 foot longer, I could have cut 4 segments from it. So each of hers are twice as long. So let's just draw those up. And she said, if she could have cut 1 more, she would have been just 1 foot longer. Her length of ribbon would have been 1 foot longer. So this isn't quite the scale, this drawing, but each of these are now 2x. And actually, this length would be such that it's one unit less than the total length of the other one. So we can represent this, if it's the same exact length as this ribbon, we can call that 8x minus 1, because we ended up being 1 foot longer. So, and those 2 expressions should represent the same length, so we can just make an equation saying they're equal to each other. And we can do the same thing to both sides here, subtract 7x, and we get x minus 1, then we just add 1 to 2, and we get x equals 3. So let's just see how that works out. So if we have 3 7 times, that's 21 plus 2 equals 23. And if we have 2 times x, that's 2 times 3 is 6. If we have that 4 times, that's 24 minus 1 also equals 23. So, all right, let's do one more problem here. We'll do this physical science problem. Actually, you know what? We'll do this clothing store one. It says a customer wants to use 2 discount coupons on the same order. One gets $10 off, the other gets 15% off. You're not sure which discount to apply first. So it says write an equation to calculate the final price of the order if you apply the $10 discount and then the $15 discount. So first you're going to take $10 off, and then so let's just let y equal our order, the total after all the discounts, and we're going to let x equal how much we're buying in the store. So we buy X dollars worth of stuff, and here it says we need to apply $10 discount first. So we're just going to subtract 10 from that total, and then we're going to apply the 15% discount. Well, 15% discount means I'm taking 15% off of the price. If I take 15% off, so the price is originally 100%. If I take that off, I end up with 85% that I'm paying. So we take the $10 off, and then we're going to multiply that by 0.85 to get the total. All right. Part B says write an equation to calculate the final price of the order if you apply the 15% discount first and then the 10% discount. So now our X is what we pay for. If we take 15% off of that, that means we're going to have to pay 85% of the price. And then we're going to take $10 off of that, which is just subtracting 10. And then C says, which order gives the customer a better deal? Does it depend on the original cost of the customer's order? Let's just pick some arbitrary price, like let's say we have $100. We want to spend $100 at both places. Now that's what we're putting in for X. So for the first equation, Y is equal to 100 minus 10. And then we're going to multiply that by 0.85. Well, that's 90 times 0.85. Which Caleb tells me is 76.5, so $76.50. All right, let's spend $100 at the other store. So Caleb, what is 0.85 times 100?
85.
That's 85. We probably could have done that in our head. And then we're going to subtract 10 from that, and we end up with $75. So we can see that taking the 15% discount first, at least in this case, it ends up being a little cheaper. But the question says, does it matter, depend on the original cost of the customer order? Well, let's just try that. Let's say we are spending $20. So if we get $10 off of $20 first, so we do 20 minus 10, that's 10, and then we multiply by 0.85, and that's $8.50. In the second way, if we take 15% off of our $20 first, which to do that we're going to take 0.85 times 20, that is equal to 17, and then we subtract 10 from 17 and we end up paying $7. It seems to me that we are always going to be $1.50 better off if we do it this second way, using this equation, taking 50% off first, and then subtracting 10. That would be my conjecture here. All right, that's the end of this video. I'll see you tomorrow.